Alright there, my name is Phil Wickins and I'm here to give you another delve in for 12 Min, a series of online CPD for teachers on the computing curriculum. Right then, today we're going to cover two separate things. In here we're going to cover decomposition and also some pattern recognition too. Right, let's get started. So, I'm covering two things today. I'm going to squash them both into this delve in for 12 Min. Not that they're particularly related, but we'll see. Decomposition is in the national curriculum for Key Stage 2. They have to know what decomposition is, or at least be introduced to that concept. Think of it as facing a brick wall, not knowing what to do, but then being able to take brick by brick apart until you can get through it. So very similar to a maths problem, you'd want to break the problem down into smaller components. If it was a multi-step problem, for instance, you could then look at each part individually before then giving the whole entire solution. So decomposition is extremely important in the pre-coding time. So before you actually begin to code, once you've been given your task, in your design process, and we talked about this in our levels of abstraction, hi Jane, in the previous video on design within computing, have a look at that one first. But in between your task stage and your coding stage is your design stage. This ultimately is where decomposition comes into its own. In terms of doing this in the classroom, there's lots of different analogies that you could relate this to. You could use the example, I can't use any other word, example of the police solving a crime. They wouldn't just walk in and immediately try to guess who it was or make any kind of assumptions or lay any blame. They would need to gather facts first. They would need to break down the problem. They would be asking, well, who are the suspects? Let's get all the information first. And then they would break it down into, well, who has an alibi? Who was at the scene? Where the crime took place? And they would begin to break the problem right down into its tiny components before they can start to piece together and grab the bits they actually need to solve the problem. Now, decomposition often goes hand in hand with abstraction, which is where you're kind of leaving out all the unnecessary detail and just literally going for the bits that you need. Okay, there's some great demonstrations of abstraction. If you look up in the Barefoot resources, have a look at what they say about it. BBC Bite Size also talks about abstraction to do with cats, I think. Very good, have a look at that as well. Okay, so decomposition, breaking it all down, how are you going to solve this problem, would come into those four levels of the four levels of abstraction that we talked about in that other video in the design process. You may also get some within your coding process as well, and you may think, well, I need to break this bit of code down. What am I actually doing here? How can I make this more efficient? Which brings us on nicely to pattern recognition. In your decomposition, as you're spreading everything out and you're having a look at what you need, you may spot patterns. Children may spot patterns in what they've got. And they may think, well, hang on, if this sprite is doing this and I've already coded that, and this sprite is also doing that, can I use the same bit of code? Is there a pattern there? If this sprite has to do this action multiple times, and I've coded it separately each time, could I do something where it brings all those bits of code into one single bit and I reference it every single time? Let's have a look at this Scratch project. Now here, I've got the cat moving around the screen, leaving a lovely rainbow trail of Scratch cats. What could be more pleasing to the eye? Now you can see that I have programmed in, each time I press the up, down, left or right, I've programmed the entire bit of code you need, or I need, for it to change color, make a stamp, and move, and point in a particular direction. Now, if you look, under each one of those arrow keys is almost the same piece of code. And I've repeated myself there, and I've spotted that there's a pattern. Now, what I could do is I could take those exact same pieces and put them all together somewhere, and then reference that piece of code. Now, I could do that in one of two ways. I could use the broadcast function, as is demonstrated here. And in this instance, it's broadcasting a message, and when the message is received, it will run that particular bit of code. However, you could also use the make a block function, and you could create your own block which will then run that bit of code when referenced underneath your direction arrows. You could take this to quite an advanced level where you've used the make a block and a number to generate which direction you're pointing in, as you can see in this, or as is illustrated here. And this also removes even more information and makes it more streamlined. There's lots of different reasons why you'd want to do this. Two of the main reasons are you could then use that code. If you have a bit of code, you could then use that over and over again in different circumstances. So you could keep that bit and put it in your next project or your next sprite. Another reason is it's tidied it up. It's made it much more easier to navigate around your code when you come to either debugging or changing, editing, adding to it. You know exactly where you are because everything is succinct, it's short, it's neat, and it's tidy. Now, some people might call this a form of abstraction. You've kind of got rid of all the unnecessary, you've tidied up. Some people might also call this encapsulation, especially if you're doing object-orientated coding, where, for example, you might have a load of different cuboids in your space. You don't need to program each one of those. You have a general cuboid program or code, and you reference that each time you want to make a cuboid, and it's got all the properties within that part, within that module. Okay, so when the children are familiar with this concept, this pattern recognition of tidying up, of sort of taking out the unnecessary or the repeats and encapsulating it, or generalizing it, however you want to say, then you've introduced them to this concept that will come in very helpful as they grow on and grow into more advanced computing. So there we have it, decomposition, breaking it down, pattern recognition, making sure that you can see these patterns, see what goes together. In terms of pattern recognition, if you wanted to start off a little bit more simple, you could have a piece of code where you've got move 10 steps, and then later on move 10 steps again, and then move 10 steps. You could change that into move 30 steps, where you're tidying up, you're spotting the patterns, you're saying, well, I don't need all of this. Maybe I could tidy it all up, or even use a repeat function, a loop function. And if you want to know more about that in detail, head over to my video on repetition. But hopefully you can start to guide these children into these more detailed concepts of where they're going, and hopefully they can use these in their Scratch projects. So please let me know how you get on. Hopefully this has been helpful for you, and I'll see you for the next Delve In for 12 Min. Thank you, goodbye.